All right, good morning, everybody. So today what we're going to do is we're going to go through and we're going to talk about what happens to food webs and food chains when we have changes in the number of births and deaths in a population. And then we're going to talk about reproduction and energy. And reproduction and energy is actually going to lead us into what we're going to talk about for the last 2 weeks of the school year, where we talk about photosynthesis, cellular respiration, how organisms take how they use energy essentially. So remember to take notes while we go through. Okay. Uh, the objective for today is that you guys will be able to explain how the increase or decrease of births and deaths can affect an ecosystem, and specifically how can it affect the food web overall. Now, what we're going to do is we're going to go through this specific example, and this is actually from Amplify. And in this example, they talk about studying jelly populations. Okay. So, an ecologist is a scientist who studies interactions of organisms with one another and their environment. So, this is someone who goes out into the environment and they study how organisms interact with each other. So, one thing that ecologists investigate is why sometimes the number of organisms in a particular area changes very rapidly. Okay. So, why, all right, would the number of organisms either drop significantly really quick or would they increase significantly? They study those things. Now, the ecologist from this video that studies jelly population, that population includes all the jellies in a certain area. The jelly population is part of a larger ecosystem made up of many populations of organisms that live in that area. Remember the definition, we have a organism, a population, we have a community, which is a bunch of different things interacting together, different species, and we have an ecosystem. Okay, those that community interacting with the abiotic factors. Population sizes can decrease, stay the same, or increase. Okay, so ecologists are especially interested in populations that change size quickly. All right, so remember the definitions for these two things: population, okay, same type of organism living in the same area; ecosystem, all the living and non-living things interacting. Now, the birth of animals adds organisms to a population. Okay, I'm not going to show the video just because, for whatever reason, it doesn't really work that well as we're going through with the Screencast-O-Matic. Okay, the death of animals removes organisms. Okay, so in the video, it uses an example of liquid in a container to show that for a system to be stable, the amount of something being added is to it needs to equal the amount being taken away. If births or deaths change, then the balance is disrupted and the population will change. If there are more births than deaths, then the population will increase. If there are fewer births than deaths, then the population will decrease. And these will have effects on the rest of the ecosystem. Okay? We talked about this a little bit yesterday when we were talking about an apex predator. If there was a huge surge in births, okay, you can expect that the thing they eat may run out. Okay? So, what ideas do you have about what could cause the number of births to increase in a population? Okay, so why would a population of organisms all of a sudden their births increase? Okay, maybe there's more resources. Maybe the climate is better. Sometimes organisms only reproduce at one specific time of the year. All right. Now, these are some important vocab that you guys need to know. Energy storage molecules. This is a molecule that organisms can use to release the energy needed to survive. These are usually going to be our sugars, so starches, glucose, things like that. All right, a population that eats organisms from another population, that's going to be consumer population, and then our resource population, a population that is eaten by organisms from another population. These are going to be a lot of our primary producers, okay? Now, reproduction, that's the process of where we create something new, new offspring. Energy is the ability to make things move or change. Now, All energy comes from the sun. That energy is used by plants, okay, to grow. And then we use the energy from the plants, okay, or something else, and then we consume that something else. All right. Now, one of the things that I want you guys to do is if you log into the populations and resources simulation, which I'll show you guys how to do that in a second, you can practice and play around with the simulation, and it's really helpful to like go through and see how one thing can affect another. So we'll go through that in a second so you guys can practice how increasing births and deaths, things like that, can cause a change to the entire ecosystem. All right? Now, remember, these are some of the things, energy molecules. Fats are things that we store inside of us for use later. Glucose is something we use right at that moment. Same thing with starch, but these are just complex. They're a little bit bigger than just straight glucose. Okay? Must skip these real quick. Now, I want to go to the changing the number of births in the simulation. Okay? Remember that the arrow is pointing toward what is the consumer. So the fox is the consumer, the vole is what's being consumed. Okay? What you guys are going to do is you're going to play around with the simulation. You're going to see what happens to the food web as you change things in it. Okay? All right. You're going to increase the bursts in the population in the sim. You're going to focus on increasing the bursts in the WeBug population. First, you'll need to figure out where WeBugs get energy storage molecules. Follow all the instructions, and once you've completed them, answer all the questions at the end of the activity. Now, what I want you guys to do is launch the resource sim or populations and resource simulation video. Observe the WeBugs. Okay, be sure to look at the food web overlay. Okay, and what I want you guys to do is really just focus on that today. I don't even want you guys getting into the CER yet. Um, I'm gonna go over that a lot more tomorrow. Today, all I want you to do is go through these notes, play around with the simulation, and then when you're done with that, that's pretty much it today. And just answer the check-in question. All right. Tomorrow, I'm gonna give you guys your instructions for the CER question, the last slide that you guys need to do for your project, which again is due on Monday. Um, but don't worry about that till now. Try to get everything, all your slides done up into slide 5 right before that. Okay. And then go through the simulation and work on that. Okay, so let's remember how to get into Amplify. You're going to go in through Clever um, and then click on the Amplify link. Remember, it's the orange little tab. Then what you're going to do is you're going to click on the little hamburger over here, scroll all the way down, okay, until you get to Populations and Resources Sim. Okay. Once that loads, what I want you guys to do is play around with it and see what happens, specifically when you change the WeBug population. All right. So let me make sure that this loads real quick and then we will go through it. So when you go into the simulation, you're going to see something like this. And in the first one, there are 3 different types of organisms. When you click on this bar over on the side, okay, you can see this is the number of greenleaf, this is the number of WeBug, and this is the furbill. So it looks like the furbill population, which is in this situation, this is our apex predator on the top, okay, eats the WeBugs eat the greenleaf, and the greenleaf is our primary producer. So play around with it and see what happens. So let's take the furbill population, which is supposed to be on the top, and let's see what happens when we increase its population significantly. Okay, hitting play, and let's just look at the numbers. We can see that it looks like the furbill population is dropping. You can also go over And after this all loads, you can click on Analyze, and you can see what happened. So you can see how the population increased really quick. That led to a slight decrease in the things that it ate. And because that led to a slight decrease in the things that it ate, it led to an increase in the plants. Okay? You can go back over to run, and let's just do this one now. What happens when I drop the green leaf population all the way down to 0? What do you think will happen? Okay, so let's see. Click play. And we can see the wee bug population slowly dying. We can see the furbill population slowly dying as well. And because there is no green leaf, there is no plant, okay? There's no primary producer. There's nothing for these two to survive on. Because if there's no green leaf, there is no wee bug. And if there's no wee bug, there's no furbill. Okay, so plants are really, really important for this whole process. And when we go to analyze and we're looking at this, we can see these numbers start dropping, and eventually they would go all the way down to 0. So what I want you guys to do today is just play around with that. Play around with what happens, okay, in the simulation. You can do this 3 organism population. You can also go down and you can do 6 populations, which is a lot more complex. In this case, we've got greenleaf, weebug, stingwing, furbill, scalebeak, and clawcat. Looks like clawcat's at the top. Okay, so play around with it. See what happens when you drop the numbers down for the clawcat, say to 0. See what happens when you increase the greenleaf. Just play around with the simulation today. Okay? Now, again, I don't want you to worry about the slides today unless you're not caught up and you're not on slide 5. I want you just to go through the video, play around with the simulation, okay? Spend maybe 10, 15, 20 minutes going through the simulation, making sure that you can understand those concepts of how things change. And then tomorrow, we're going to go through the last set of notes, and I'm going to go over what you guys need to do for your CER. All right? If you have any questions, again, email me, hit me up on Google Classroom, and if not, practice this simulation and have a great day. Bye, guys.